Entropy is often described as disorder, but that word hides more than it explains. Disorder sounds like decay, collapse, or failure. Entropy is none of those things. Entropy is accounting. It is how the universe keeps track of change. To see this clearly, we have to stop thinking of entropy as something that happens to systems and start thinking of it as something that records what systems have already done. Whenever a system changes, something is spent. Energy is redistributed. Options are reduced. Paths that were once possible are no longer available. Entropy is the measure of that loss of flexibility. It tells us not how messy a system looks, but how many ways it could still be rearranged without additional work. This is why entropy always increases in real processes, not because the universe prefers disorder, but because once a change has occurred, it leaves a trace. That trace cannot be undone for free. Consider something simple: ice melting. When ice melts into water, energy flows from the environment into the ice. The molecules gain freedom of motion. The system now has more possible configurations than it did before. That increase in entropy is not destruction. It is a record that energy moved and work was done. To reverse the process, to refreeze the water, energy must be removed again. The universe remembers that the melting happened. The same logic applies at every scale. A star shines by burning fuel. That process releases enormous amounts of energy into space. The light and heat radiated away are not accidents. They are the cost of maintaining the star's structure against gravitational collapse. The entropy produced by that radiation is the universe's record that nuclear fusion occurred. When the fuel is gone, the star cannot simply decide to keep shining. The accounting has already been done. Memory works the same way. Any system that stores information must change internally. A computer flips electrical states. A brain alters chemical gradients and synaptic connections. A physical record, like a fossil or a footprint, exists because energy was dissipated when it formed. In every case, remembering requires work, and that work produces entropy. This is why entropy is not the enemy of memory. It is the price of having memory at all. A perfectly reversible universe, one with no entropy production, would be a universe with no history. Nothing could leave a trace. Nothing could remember that anything had happened. Every process could be undone without cost, erasing its own past. Such a universe would contain motion, but no narrative. Change would occur, but nothing would persist long enough to matter. Entropy gives time its arrow, not by forcing decay, but by ensuring that events leave irreversible marks. It is the reason causes precede effects in any meaningful way. It is why the past is fixed and the future remains open. Entropy is not about things falling apart. It is about the universe refusing to forget what it has already paid for. This also explains why entropy and information are inseparable. Information is not an abstract substance floating above physics. It is the physical trace of differences that have been established and maintained. Those differences exist only because energy was spent to create them. Entropy tracks that expenditure. It tells us which distinctions are real, which changes are locked in, and which paths are closed forever. When people say entropy measures disorder, they miss the deeper point. Entropy measures commitment. It measures how much the universe has committed itself to a particular history. Once entropy increases, the universe cannot return to a previous state without additional input. That asymmetry is what allows structure, memory, and causality to exist at all. Entropy does not erase meaning. It makes meaning durable. In this sense, entropy is not a force pushing systems toward ruin. It is the ledger that records which changes were paid for and which remain possible. It is the universe keeping score, not judging outcomes, but remembering them. And that brings us to the next question. If entropy records the cost of change, what determines the direction change takes in the first place? Why does motion consistently flow one way rather than another? To answer that, we need to talk about gradients. I'm Charles Carroll, and thanks for listening.